Hi, hello, I'm Kiran Kumar from Nature of Physics. Today's topic is elongation of the rod due to its own weight. Welcome to my channel. Please like and subscribe my channel. See here, this is the uniform rod. Of area of cross section is capital A and length is capital L and its own weight is W. Weight is gravitational force acting downward direction on the rod. Now the rod is first connecting to the rigid support and another end is freely suspended. That is vertical rod, vertically suspended. Now we wanted to find elongation in the rod. The elongation is different in the rod. More elongation at the free end of the rod because of weight acting at the end of the rod. And for the derivation of elongation, considering small element is dx at a distance x from the free end and remaining distance is L minus x. Here L is the length of the rod, E is the small elongation due to its own weight. See, now longitudinal stress, So that is force acting per unit area, that is restoring force per unit area. So longitudinal stress, which is equal to weight per unit length into x divided by area A. So weight per unit length into x represent here force, restoring force. For example, x is equal to L get cancelled, then weight is the gravitational force divided by area remaining same only, that is restoring force per unit area. Okay, so now next we have to discuss about the Young modules of the rod. So Young's modules. So for Young modules, y which is equal to longitudinal stress divided by longitudinal strain. So longitudinal stress divided by longitudinal strain. Okay, so here stress, longitudinal strain. So try to understand here longitudinal strain is delta L divided by delta X. Generally we write that is E divided by capital L, that is elongation divided by original length. Here I am taking elongation is delta L and length is taken as for the element is dx because of we are finding derivation with respect to element delta x or dx. Okay, so then continuation step I am replacing in the above equation. So y which is equal to longitudinal stress divided by this longitudinal strain, that is delta L divided by delta X. Rearranging this equation, that is y which is equal to longitudinal stress divided by dl divided by dx. So y which is equal to longitudinal stress, okay, L dl into dx. So now dl which is equal to longitudinal stress into dx divided by y. So this is taken as equation number 1, this is taken as equation number 2. Now equation 1 in equation 2. So dl which is equal to longitudinal stress, that is W by L into x, okay, into dx divided by, here the remaining value is y. Okay, whole divided by A. See, here A is there, here A. Just a second. See now, just I took first longitudinal stress, force per unit area. So here longitudinal stress is equal to weight by length into x. So that represent the weight, that is force only we are taking as a restoring force, and divided by area, so F by A, so this value. And next, Young modules, which is equal longitudinal stress by longitudinal strain. So longitudinal strain is delta L by delta X with respect to element taking, and Young modules is equal to LS divided by dl into dx. Now here we can write dl is the elongation, so longitudinal stress into dx divided by y, taken as equation number 2. Now equation 1, in equation 2 we got dl value. Yes, just a second. And continuation, now rearranging this equation. So dl, which is equal to wx into dx ya into L, and integration on both sides. 0 to L is the limit. So 0 to L, length of the L is the length of the rod, and integral dl is L. Okay, w divided by yal is common, integral 0 to L, that is x into dx. So w divided by yal x square divided by 2, 0 to L. Lower limit and upper limit are replacing. L is equal to w yal L square divided by 2 minus 0 square by 2. So here L square L is get cancel. Now the resultant equation L, which is equal to W into L divided by 2 into YA. And continuation, here we can replace weight W, which is equal to mg. So L, which is equal to mgl divided by 2y into A. So here E is equal to elongation. So now I am replacing small l is what? Elongation. Okay, so we got here elongation, which is equal to mgl divided by 2y into A. One more step is there, just a second. Now continuation, here already we got two equations. First one, elongation is WL by 2YA, and second mgl divided by 2YA. So next, mass replacing here. So density, which is equal to mass by volume. So here mass is equal to density into volume is area into length. So here V is equal to area into length. Now continuation, the value is replacing in this equation. So E, which is equal to rho AL into GL divided by 2YA. So here AA get cancel. So elongation, next equation E, which is equal to rho G L square divided by 2Y. So this is the elongation. Okay, elongation is directly proportional to the square of the length of the rod. Elongation is directly proportional to the square of the length of the rod. So this is the elongation of the rod due to its own weight. Just a second. So we got different form of elongation equations. This is the first equation. So this is the second equation, and this is the third equation for the elongation, because of L is taken as E here for the elongation of the rod. Please like and subscribe my channel.